Okay, I'm going to walk you through the math for experiment 4. You're going to want to use a spreadsheet to do all this rather than by hand. Otherwise, you will probably make one mistake, and that mistake will propagate and pretty much ruin your results. So here I have a spreadsheet set up. I have 4 tabs. Let me talk about what's on these tabs. The first one is yield, and that's going to be your grams of the starting material of the ammonium iron sulfate that you used to make the green crystals, and just some molecular weight on the side. Here is your mass of your green crystals after you did vacuum filtration, and down here I just have some molecular weights that are handy to have on for these calculations. On the second tab I have the calibration tab, which you took maybe 2.6 grams of your starting material, ammonium iron sulfate, which has a molecular mass here, and you made your dilution into 100 mils and then 2 mils, and then further into these sample dilutions, of which you recorded the mils of the iron BIP solution as well as the water you put in, and then you got some percent transmittance for those dilutions. On the third tab is your unknown. It's your mass of green crystals that you used to make iron BIP, the volume of those aliquots, and from there you made, once again, 5 dilutions with some amount of iron BIP, some amount of water, and you measured some percent transmittance. And lastly, you're given some ratio information that the oxalate is 53.7% by mass weight, right? So by mass. So that's how we're going to set up our spreadsheets, and I'm going to break this down into 4 different parts to solve this problem. But I'd like to add one more part here, and that is how are we actually determining these dilutions. We're going to use a very simple equation to actually determine these dilutions, and that equation is M1V1 equals M2V2. You can think of maybe M1 as being your stock sample, and your V and your 2s are your dilutions. And so let's talk a little bit about what that would look like. So maybe you have M1, volume 1, M2, volume 2. Okay, so maybe you have a master solution that's, I don't know, 5 molar. I don't know. But what you want is, you want, let's say, 100 mils. So as long as the volumes are in the same mass, units, milliliters or liters, we can just use the same number. So 100 mils, and you want this to be maybe 0.2 molar, or maybe something weird, 0.35 molar, okay? So how much of that volume would you have to add to a bottle and then fill up with water to get to 100 mils of the solution? Well, you're just going to use this equation. So because to get what this V1 is, it's just M2 times V2 divided by the M1. So simply V1 is your other side divided by this volume, or this molarity. And so you'd have to put in 7 mils of this 5 molar solution and then top it off with 93 mils of water, and you would get a 0.35 molar solution that's 100 mils. So that allows us to calculate that. Or maybe in the case of your situation, you have something where you know the molarity, and you know how many mils you've added, and you know your final mils, like maybe coming out of one of the samples, is 7.5, and you want to know what that molarity of your dilution is. Well, that molarity is just the concentration of your stock times the amount of your stock divided by the volume, or your final volume of the solution. And so that will give you the molarity of maybe your first dilution in these series.